Okay, so here we'll check the design result of STAAD, no? But this time we'll be using ASD, no? So ang ginawa ko sa command file, instead of using LRFD here, ginawa ko siyang comment para ma-ignore siya ni STAAD. Then ang gagawin niyang code is ASD kasi yun yung may available akong spreadsheet to verify the design. And I'll be using, instead of 1,000, let's use 3,000. Ito kasi yung ating ASD load combination. So kailangan consistent, no? ASD to, ASD yung code, and yun yung gagamitin ni STAAD for the design. Okay, so minanipulate natin yung STAAD editor, inedit natin to, yan, and proceed with the analysis and design. So I close this, then run analysis, okay, and then post-processing for the design, no? And same process, layouts, utilization ng beam results, yan. So first, let's check sino yung may maximum utilization ratio, yung demand capacity ratio. Okay, tayo dito. So 0.932. And if I click this, so by the way, naka-filter lahat ng column. So among the columns, so siya ulit, no? Siya ulit yung malaking demand capacity ratio. So as you notice, even when we transition to ASD, kanina LRFD, siya pa rin yung nag-govern na member. Okay? And 0.932 yung demand capacity ratio niya. This time, sa ASD. Okay? ASD code. Now, if you wanted to check yung sa beam naman, punta naman tayo sa beam, right-click, result setup. So, let's choose lahat ng beam. Ito yung beam natin, no? Apply, okay. And walang failed members. Okay. Yan. So, na-select na lahat ng beams. And punta tayo sa actual ratio. And if you will notice, siya pa rin. It's the same member. Sa ASD, ito pa rin ang nag-govern. Okay. And ang ratio na niya ngayon is 0.62. Okay. Let's verify first, no? Itong member na to. So, siya, still design. Okay, ito yung mga properties. Ito ulit yung mga allowable. And let's open yung ating spreadsheet for the beam. So, ito din siya. Minimize ko to. Yan. So, what I did is, kinuha ko yung equivalent section nitong 760 by 196 sa ASD. No? Kasi ito ay Canadian. Yung Canadian section yan, okay, doon sa database ni STAAD, no? Then, if you will notice yung property niya, yung depth niya, 770 mm. Then, itong napili kong W30 by 191, check natin. Yung 770, convert mo sa, sa inches, you will get about 30.7. No? So, which is pretty close, no? Next, yung flange width na 0.268 meters. So, 268 mm yan. 268 mm. Kunin natin sa, sa, what do you call that? sa inches. So I'm getting 10.72 inches. So 10.72 divided by 25. So that's about 10.7 inch. So palitan natin to. No? So it should be W30 by 132. Yan, ito na pala yan. Yan, yun na. So equal na sila. 10.5.268 meters. How about yung web, thickness ng web? That is 16 mm divided by 25. How many inches yon? 16 divided 25, I'm getting 0.64 inch. 0.64, which is pretty close, 0.6 inch. Okay. And last is, okay, thickness ng web is, okay, so thickness ng web, according sa aking checking, it is 25.4 mm. And with this, thickness ng flange, so that is 1 inch. So tama naman. So in short, this W760 by 196 is equivalent to W30 by 132. Okay? Next is yung forces. So naglagay na lang ako ng small load, P and MY, para lang hindi siya mag-error. Then, ang lumabas na maximum moment natin is 377 kilonewton meter. Convert natin sa keep fit kasi yun yung nare-recognize ng spreadsheet. So, multiply natin sa 3.28 divided by 4.44. Ito to convert into meter. And then, ito naman is to convert from kilonewton to kips. So, ito is to convert to feet pala. Ito naman is to convert into kips. And we got 346 kip feet. Okay, what else? Yung length ng beam natin is 7.5. So, that is equivalent to 24.6 feet. Yan, lagay natin, no? 24.6 yung length ng beam. And basically, yun lang. Yun lang input natin. 36 KSI naman siya. Okay, what else? So, that's it. And then, makakapag-come up na siya ng allowable stresses. Yan. Allowable bending capacity. Allowable bending strength. Bending sa X bending. Capacity sa Y-axis bending. And from that given value, ang nakuha niyang 0.786. Okay. Okay, versus sa STAAD na 0.62. Okay, let's see kung may na-miss pa ba tayo. So, 27.5. Okay, so which is pretty close naman. 0.62 versus 0.786. No? Okay, what do we miss here? 376. 377. 278 pala. Sorry. To convert. Yeah, so this should be 278.5. Yan, so close na siya. 0.636 yung demand capacity ratio niya. versus kay STAAD na 0.62. Okay, let's further check yung mga capacity ni ni spreadsheet. So for example, ang kanyang actual capacity is 8.68 KSI. Kay STAAD is 61.08 megapascal. So multiply lang natin to sa around 7, no? To convert KSI to megapascal, di ba? 8.68 times 7. Oh, so that's about 60.76, which is almost equal dito sa ating compression, actual compression, no? Capacity. Allowable compressive strength. Next is yung kanyang bending strength, no? At x-axis. So 14.6 multiplied by 7, you will get 99.12. Okay, 99.12. By the way, yung author nitong spreadsheet, si Alex Tomanovich. So, searchable naman siya sa Google. 99.12 bending X, which is this one. Diba? Pretty close, no? Yung kanyang compression bending. Okay? Next is ito naman sa y-axis. Diba? Na-discuss ko kanina. This is Z, this is Y. So, yung kanyang strong axis bending capacity is Z, which is ito. Then, yung weak axis bending niya is Y. So, ito naman siya, which is FBY, 27 KSI. No? Allowable bending capacity sa weak axis. So, multiply by 7. So, we got 189, which is pretty close dito. So, 186 kay STAAD. Okay? So, that's how you manually verify, no, yung output ni STAAD, no? Okay? So, that's for the beam. So, dito may propose siya ng mga alternative section that you can use. Okay? So, that's for the beam. Then, let's proceed naman sa column. So, we know already kanina na ito nga siya, no? Yung may maximum demand capacity ratio. So, ulitin natin. Labasin natin siya. So, R1, apply, okay. Having 0.93, no? So, sagad na yan. I suggest, okay na yan, yung ratio na yan, no? So, double click. So, it's the same section. Okay. Then, proceed naman tayo sa spreadsheet ulit. This time for the column. So, same section naman. So, na-verify na natin yan. Ito pa rin yun. No? Let's just input yung mga forces. So, here, ang nag-govern naman sa kanya ay load 313. So, yung actual niya is FX 1066.32. So, 1066 divide by 4.44, you will get 240.1, no? 240.1 kilonewton. Kips. No, kasi kilonewton to eh. So, 241 kips, ito siya. Okay. Next is for the moment. Okay, let's so please listen here kasi so si STAAD may MYMC. So that's why this is the important yung yung inexplain ko kanina na bending, no? So, zeta, this is y sa local axis, no? And you will notice yung strong axis bending is z. That's the mz, no? Strong axis. Ano ba yung strong axis natin sa spreadsheet? X. And according dito kay STAAD, yung MZ natin, which is the strong axis bending, is just 5.46. Yun yung na-absorb niyang moment. So, upon converting into keep fit, that is only 4 keep fits. Keep fit. So, ito yun. Nilagay ko siya sa MX. Yan, MX. Maliit lang, no? So, you can imagine, ito yung, ano na yun, ito yung bending moment na yun. 4 keep fit. Then, sa MY, which is, ito, the weak axis, ang na-absorb niya is 69 kilonewton meter. Medyo malaki, no? 69.32 kilonewton meter. And if you convert that into keep fit, that is 51.21. So, you can imagine now, kung ito yung column mo, andito yung 51.21. Dito siya nagbe-bend. 51.21. So, ang laki nung na-absorb niyang moment sa weak axis. That's why, kaya mataas yung utilization ratio niya. Nag-absorb siya ng malaking moment. Okay, so yun yung maganda, no? Pag alam mo yung may manual way ka of checking yung forces, no? Sa spreadsheet na nare-realize mo bakit tumataas yung demand capacity ratio sa design. And that's it. That's the main reason nag-absorb siya ng malaking force sa weak axis. Maliit yung capacity niya sa weak axis. So tingnan natin, no? And i-input ko din yung 3 meter height. So 9.84. Yan. And that's it. Ang lumabas din yung capacity ratio is 0.93. So which is pretty close kay STAAD. Okay? And let's see, let's compare yung mga capacity niya. So ito siya. Yan. So yung allowable axial compression niya is 18.13, which is this 124. Okay, so times 7 natin to. So that's pretty close. 127 ang nakukompute ko. Okay, which is pretty close sa 124. Okay, yung kanyang x-axis bending, yung capacity niya sa strong axis, 21.6 times 7. I'm getting 151.2, which is pretty close dito, 148.8. Then, pagdating sa weak axis bending, ang kanyang capacity is 27. Take note, no? Yung kanyang actual bending, 16. Dito sa strong axis, yung kanyang actual bending stress is just 0.13. No? Napakaliit, no? Compared sa weak axis bending, 16 KSI. Talagang nadikitan niya yung weak axis bending capacity, which is 27 KSI. And if we check that, 27 times 7, that is 189 KSI, which is this one. Pretty close sa 186. And that's it. So, ito yung nag-drive nga ng kanyang malaking utilization ratio. No? And so, that's it. So, we were able to verify yung ating yung design ni STAAD, no? Using ASD.